Hello again. In this lecture, we're going to learn about multiplying radicals. Now, before we get too crazy with multiplying radicals, let's go over the two rules that we are aware of. The first rule is that if we have the square root of anything squared, that is just that anything, whatever a may be. Same deal for multiplication. This rule, if we have the square root of two things multiplied underneath the radical, we can break it up where we have the square root of a times the square root of b. With these two rules, multiplying radicals becomes a lot nicer. So let's go ahead and do our first problem where we're asked to simplify or multiply, whatever crazy directions they might get you. Simplify is my go-to word because it basically says do what the problem implies to do. Follow order of operations. It's kind of a cop-out. So our first one that we are going to have is simplify the square root 3 times the square root 18. Now, there's many different ways you can tackle this. You could try simplifying each radical separately and then multiply them together, or you can multiply them together and then simplify in one go. I use the words simplify in our directions just to say have at it. Sometimes you might see the directions where they say multiply, then simplify. This is them trying to help you, believe it or not. They're asking you to multiply first because it'll be easier. So that's what we're going to do. We're going to use the rule from my previous page I left, where if I'm multiplying two things under a radical, let's just look at it, we can push them together under one radical. And that's what I'm going to do. So this is the same thing as the square root of 3 times 18. Now, you can multiply 3 times 18. In fact, I'm going to go ahead and do it off to the side because I don't know what it is. 8 times 3 is 24, carry the 2. 3 times 1 is 3. Okay, so I got 54. So you can multiply them together and you got the square root of 54. Now you got to simplify this. And when you simplify, you're just going to break it back down into two things that multiply together. How about 3 and 18? So this was a wasted effort. I could have just broken it down from 3 times 18. 3 is prime. 18 we're going to break down even further. We got 2 and 9. 9 breaks down to 3 and 3. Now, if there's buddies, they get to leave the radical because it's following the rule. If we have the square root of something squared, we're just left with that something. So what we have right here is 3 squared, and the square root of 3 squared is just 3. So they're going to pop out of the radical. They had a buddy, they get to leave. Now this 3 and this 2 did not have anybody, so they're stuck under the radical. There was no perfect square. Now they're still being multiplied together, which we'll go ahead and get. Oops, let me not forget my 3 out front. And we'll have 3 square root 6 is the simplified version. You can get the same answer a couple different ways. If maybe you had reduced the square root 18, you would see that maybe a 3 popped out and then you have to multiply and then another one, then it will reduce a little bit more. It's up to you how you want to tackle it. I personally do think that multiplying together under one radical is the easier way. Maybe not the most efficient, but definitely much nicer. Let's go ahead and tackle another problem. We'll use the same direction, simplify. And let's say we got something a little bit more crazy. Let's say the square root 22 times the square root 14. Now, separate right now, I don't see any perfect squares, so it's in my best interest to go ahead and put them under one radical. That's kind of our clue. We look for perfect squares. That's what makes us put them under one radical. And now we have 22 times 14, whatever that may be. I'm not going to waste my time multiplying it because I'm going to find the prime factorization anyways. 22 can break down to 2 and 11, both prime numbers. 14 can break down to 2 and 7. And now the only partner we see teaming up here is the 2's, so a 2 gets to leave. The 11 and the 7 are stuck under the radical, so we'll multiply them together. And we have 2 the square root times the square root 77. So these are all nice. Let's see one terrible one. Let's throw in some variables for our funsies. we have the square root of rs times the square root of st. No numbers. Now, once again, it doesn't make a difference how we want to do this. We can't simplify actually in this case, so we're going to bring them under all one radical. We have rs times st. Now, remember, what's going on between these variables, they don't write it. Mathematicians are lazy, but it is all multiplication. And when we multiply these together, we can see we have s times s, which is the same thing as if we were to write s squared. And since the square root of something squared is just that something, that s gets to leave the radical. But r and t didn't have any buddies, so they're stuck under the radical. And that's pretty much what we're doing with all multiplication of radicals.